Hello everyone, this is the North American Math Contest Go Go Go. Today we are going to do another problem. This is the last problem of this year's format. In the 3 times 3 grid shown, the central square contains the integer 5. The remaining 8 squares contains a, b, c, d, e, f, g, h, which are each to be replaced with an integer from 1 to 9 inclusive. The integers can be repeated. There are n ways to complete the grid so that the sum of the integers along each row, column, and diagonals are all divisible by 5. What is the rightmost 2 digits of n? So what we do, by simple inspection, you will find that this problem is way too hard. It is not able to solve. So we have to start from the small things first. For now, we can neglect the B, D, E, G. Because if we have A, C, F, H determined, then it will be only choice for those 4, like squares, right? So we can just have them negligible for now. By quick observation, because we want the main diagonal to be a multiple of 5, this means that A plus 5 plus H must be a multiple of 5. What can this conclude? This can then conclude that A plus H must be a multiple of 5. What we then do is that we can test some values here for A and H. A, H. So when we find that A is equal to 1, H can be 4 because 1 plus 5 plus 4 is equal to 10. 10 is a multiple of 5. It can also be 9. 1 plus 5 plus 9 is equal to 15. 15 is also a multiple of 5. This also works exactly same for 6, right? 6. So it's 4, 9. Now we talk about now we can talk about what I call 2 and 7. When it is equal to 2, the possible values for H is 3 and 8. This works the same for 7, where they also add up to 3 and 8. Now let's talk about a 3 and 8 case. For both of them, H can be 2 or 7. So if H is equal to 3, the possible values, if A is equal to 3, the possible values for H is going to be 2 or 7. And if A is equal to 8, the possible value for H is also going to be 2 or 7. So, if A is equal to 4, or A is equal to 9, the possible value for H can be H is equal to 1 and H is equal to 6. If A is equal to 5, this one's different. H can only be 5. So what conclusion can we draw here? What conclusion for if we see a combination of A, 5B, and A is not a multiple of 5, there will be 2 different values for B. You must remember this central concept here. Because, just wait for a sec. If you don't, this will be one of the most important concepts that will be the basis for us to solve, like we do the caseworks. So you must know this theorem. If we see a combination of A, 5B, and A is not a multiple of 5, there will be 2 different values. So we can find that depends on the value of A, H will changes. So this means that H is dependent on A. We measure the exactly case to C5F. So in this case, C plus 5 plus F is equal to 15. Sorry. So this means that C plus 5F is a multiple of 5. F is depends is dependent on C. So we need to make a notation first. H depends on A would be another symbol of H is equal to, just wait for a sec, I'm choosing what format? Oh, where's the that thing? Insert, where's the insert? Underline, underline is here, okay, underline. H is equal to A. This is the symbol that we are going to make. Underline means that it is depends on one another. We are going to make this symbol. So also please remember this symbol first. We then can just use this way, we can then simplify it into a formula of this, where this form is going to be, why it got 2 pages. Where this form is going to be like this. A, C. And also we can make some decision based on that, because A and C. So this means that the value of B is going to be dependent on the value of A and C together, the sum of A and C. So it looks like this. This is what we want for now. And also we can also try to do some casework for A plus C to see what the value of A and C is going to be. So in this case, you can try calculating by yourself later, but I'm just going to tell you the conclusion for it. If A plus C is one of the values, so remember first that A plus C can only be less than or equal to 18. Must be less than or equal to 18. Why? Because the maximum value of A is 9 and the maximum value of C is 9. So the maximum value of A plus C is less than or equal to 18. So now we can do casework. If A plus C is one of those values, 2, 7, 12, 17, then A plus C is going to be 3, 8. What the hell? Okay, 3, 8. If the value of A plus C is one of 3, 8, 13, 18, the value of C is going to be 3, 7. If the value of A plus C is 4, 9, 14, the value of the A plus C is going to be 1, 6. 5, 10, 15, 5. 6, 11, 16, 4, 9. Okay. So, by doing so, you will find that the fact whether A and C is 5 or not will heavily screw the final results. So this means that we must do a casework. We must do a casework for now in order to see in which specific cases there will be how many values. So this means that we can divide it into 4 cases based on whether they are a multiple of 5 or not. In this case, since the number is ranged from 1 to 9, the only number that is divisible by 5 is 5 itself. So we can just test based on that, whether A or C is equal to 5. Let's divide 4 case scenarios. Is equal to A is equal to 5, C is not equal to 5. A is not equal to 5. C is equal to 5. So now we have those cases with us for now. We don't have to worry. I mean, theoretically we need to worry more, but we don't have to worry. So now let's remember the graph there. This is what we currently have for now. for the 3 times 3 graph. Now we need to divide the first case, discuss about the first case. So by discussing the first case, we will just simply substitute this into this. 10. And by doing so, you will find that the only value that a plus c can work is 5. Because since this is a multiple of 5, this is a multiple of 5. To make a sum of multiple 5, this also, a plus c must also be a multiple of 5. So this key can be 0, 5, or 10. However, both, remember that the problem says that it can only be, what's that called? It can only be in 0, 1 to 9, right? So this means that this can also only be 5. We use the same concept from here. We know that this one must only be 5, and this one must only be 5. And then we apply the same concept to the rest of the 3 grids. Because multiple of 5, multiple of 5. This must be a multiple of 5. However, the only multiple of 5 within 1 to 9 is 5. So therefore, the only way for this type of combination is this. Okay. So now let's look at the second case. A is equal to 5, C is not equal to 5. We then copy back the, what's that called, the graph again here. Just wait for a sec. So we have, if A is equal to 5, so we have only one choices for him. We then have 8 choices for C. Remember, we have 8 choices for C. Because C can be any value other than 5. Why is it other than 5? Because we stated in this problem that C is not equal to 5. So C can be all other values from 1 to 9 other than 5. So C has 8 choices. For each of the 8 choices of C, there will be 2 respective choices for this one. Okay? There will be 2 respective choices for this one. For this one, however, this can only be 5. Sorry. Now I'm going to explain to you why, like, this one, right? This one can have 2 choices. Because we set the general rule here. If we see a combination of A, 5B, and C, I mean, A is not a multiple of 5. In this case, the C can be any value other than 5. There will be 2 different values for B. So since that we stated that C is not a multiple of 5, then the effective C can have 2 values. So we know that 2 choices for C. And 2 choices since C is not a multiple of 5, it will be impossible for C to be a multiple of 5. C to be a multiple of 5. C plus C must be equal a multiple of 5 due to that C plus C plus 5 is a multiple of 5. Okay, so we know that C cannot be a multiple of 5. This one cannot be a multiple of 5. This one cannot be a multiple of 5. So this means that we can just apply the general rule above here. If we see a combination of 5, A, 5B, and A is not a multiple of 5, then there will be two different values for B. This means that we have two respectively choices for each empty cell. For each empty cell. The total method we will have is we just simply time them. 2, 8. P is equal to case 2 is equal to 2 to the power of 3, which is 8 times 2 times 2 to the power of 3. So this will be equivalent to 2 to the power of 8. Great. Case 3 is simply just mirrors case 2. Case 3 mirrors case 2. Because the graph of case 3, like if you think about it in this way, this one is A is equal to 5, C is not equal to 5. Then the next one is C is equal to 5, A is not equal to 5. The third way is the third graph, like the graph in the third case, is literally just a reflection of the second case in terms of the final product of the graph. So this means that the result of the third case just mirrors the second case, which means that the third case is also equivalent. It is 2 to the power of 8. Now we need to talk about case 4 for now. Case 4, we need to divide it into some subcases. Depends on the sum of A plus C. Just wait for a sec. I'm looking for the text bar. Yes, this one. Underline A plus C. It is equal to 5. It's multiple of 5. So this is the case 4. Now we are going to put it back here. So it's like this. So since we know that it is a multiple of 5, it means that it can only be 5. Because from the integers 1 to 9, only 5 is the multiple of 5. And we know that there are A choices for A. There are 2 choices for C. There are, and respectively, using the rule above, like using, I'm going to say it one last time, the rule for the, what's that called, this one, to avoid minimum confusion, to minimize the confusion. If we see a combination of A5B and A is not a multiple of 5, there will be and only be 2 different values of B, 2 of them, 2. So this means that C and A are going to be 2 choices respectively. Okay. So for the just wait for a sec. 2 choices of the, yeah. Just remember and also for this part, there is only 1 choices. I mean, this must be 5. Why? Because this is stated 5 and this is stated 5. So to make this line, this vertical line, equal to like a multiple of 5, the number 5 is the only choice, so that it equals to 15, which will be the only possible values that can reach a multiple of 5, like the value of 5 in here. It will be the only possible values. So this can only be 5. And then for the rest of the 2 cases, there will also be 2 different values respectively. Reference the 2 main diagonals. No, never mind, sorry. So the total cases would be 2 to the power of 5 times 2 to the power of 3. Is equal to 2 to the power of 8. This is another 2 to the power of 8. Then we talk about the case 5. Case 5 is equal to case 5 is equal to A is not equal to 5. Oh, sorry. A is not equal to 5. C is not equal to 5. A plus C not multiple of 5. Why do I need to make additional 2 separate cases? I can't explain to you for now, but like once you continue looking at this video, you will see why. Once you continue to look at it, you will definitely understand it. So now let's look at this. So we have this graph with us again. Just wait for a sec. Where the hell is the original graph? Okay, it's here, it's here. So we have this graph with us again. This graph. So we know, again, we just start from the basic. A has 8 choices. C has 2 choices. AC also has 2 choices. A and C and C also has 2 choices. So we know that we state that A minus C is a multiple of 5, which then can direct to A plus C, C affected, C plus A affected, which is this plus this and this plus this are all multiple of 5. So why? You may ask me, why is this? Why is it like that? Because we can denote C as 5 minus C or 10 minus C or 15 minus C. Why is this correct? Because do you remember why we defined this one? C affected means that its value is affected by C, right? It's a value. C affected means that its value is affected by this one. So this means that we can just place them like this in order to make this diagonal. You see, C plus C affected plus C plus 5, the left diagonal, like this, left diagonal. It up to 15. So this means that if we plug them back to the first column, which is A and C affected, it will be either result will be 5 plus A minus C, 10 plus A minus C, 15 plus A minus C. All of them is a multiple of 5 because A minus C is a multiple of 5. Of the possible results will be a multiple of 5, and because A minus C is a multiple of 5. Just wait for a sec. 2, 2. So those two empty cells, it can only be filled as 5. However, this one, the second one on the bottom, the second panel, the second cell on the bottom can have 2 values because A plus C affected is not this one. This one is not a multiple of 5. And according to that rule, you remember that rule above? It is if AB and if A5B, just wait for a sec. If we see a combination of A5B and A is not a multiple of 5, there will be 2 different values for B. It's not, with cell on the bottom is not divisible by 5. So we combine all of those cases, we just can multiply them. We multiply this 8 times, we multiply them, those all different cases. A affected, C affected, and sorry, I think I missed something here. Because it has 2 choices, remember that since that it is not a multiple of 5, this one, it also can only have 2 choices. Since it is not a divisor, of 5. So we just can simply tie P case 5. We can simply obtain this result. 2 times 2 times 2 times 2 times 2 times 8 is equal to 2 to the power of 8. Now let's talk about the last case, case 6. So now we come to our last case. This is the last case, really. So we have A has 8 choices. C has 4 choices. 4 choices, remember. This time it's not 2. Because this one, it can have 2 different choices. And this one, it originally can be, it can be impacted by both this and this. This one can lead to C have 2 choices. This one, the first row, second column grid can also lead to C have 2 choices. So like 2 times 2 is equal to 4. C has 4 choices, okay? C has 4 choices. For each of the A, C, and A plus C, it all has 2 choices. And there are 2 choices for the, those 2 doesn't exist. There are all those 2 choices. There are 2 choices in the rest of the 3 entries. There are 2 choices in the rest of the 3 remaining entries. So we combine them 8 times 4 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 64, 2 to the power of 6, 8, 11. So it is equal to 2 to the power of 2 to the, it is equal to 2 to the power of 11. So we add up all the cases together, okay? We add up all the cases together. Where we get the first choices, it has 1. The second choices has 2 to the power of 8. The third choices has 2 to the power of 8. The fourth choices has 2 to the power of 8. The third choices has 2 to the power of 8. The fourth choices, it has 2 to the power of 8. The fifth choices, it also has 2 to the power of 8. And the sixth choices has the possibility of 2 to the power of 11. Just wait for. So it adds up 2 to the power of 8 plus 2 to the power of 11. So which is equal to, just wait for a sec, 2 to the power of 3073 cases. So we know that the total number of cases is 3073. Since the problem requests us to type in the last 2 digits of n, it is going to be 73. So the number that we should be typed in for the answer is 73. Here we come to the end of our lesson and I hope you have learned a lot. See you next week. Bye bye.